Alright guys, so in this video we are going to add in transfer functions. So we'll have a different selection of transfer functions. And the first thing I'm going to do is take this sigmoid and take it outside of the class definition. So let me just cut this out because that's going to make our life a lot easier. So let's say classes, and then we'll say transfer functions. And you'll see why this is much better later. Okay, so it's the exact same thing except I remove the references to self. Out times 1 minus out. And then every place it's used in the network, so in run, I don't call self.sigmoid, I just called sigmoid. And that's going to change here in a second anyway. Remove the self, remove the self. So this should still work. And there you go. Okay, actually while I'm here, let me get rid of some of this junk. And let me reformat this output. So for I in range of lv input dot shape 0. So for each row, let's print out something that's a little bit easier to read. So input, output is this. Format it with our input data, the ith row, and the network output ith row. And of course, this is going to be one of the ones that takes a while. And so there you go. That's a little bit nicer output. Okay, so let's go in here, and first of all, let's make our new transfer functions, our other ones. So SGM will be the sigmoid. We'll do linear, which is one of the most important ones. If it's not derivative, return x, else return 1. Let's do Gaussian of x derivative equals false. If not derivative, then return np.exp of negative x squared. Return else return negative 2 times x times numpy.exponent of negative x squared. And let's define tanh x and derivative. If it's not the derivative, we'll return numpy tanh of x. So hyperbolic tangent is a lot like the sigmoid, except it has a range from -1 to +1 instead of from 0 to 1. Okay, np dot tanh of x squared. All right, that ought to be enough. Okay, so then we're going to need a place in the network to store it. So let's make a property called tfuncs. It'll just be a list. I'll need a way to pass it in. So let's call it layer functions. And we'll default it to none. Now when you pass in, okay, so it has to be optional. So if I don't pass in anything, I need some sort of default behavior. So if layer functions is none, let's go ahead and do the following. So let's make a little list called lfuncs. And for I in range of self.layerCount, let's do the following. So if I equals self.layerCount minus 1, then this is the output layer. Let's just make it linear. So lfuncs.append linear. Otherwise, we need some sort of default, so let's just append the sigmoid. Okay? Oops. Okay, so that will work, and then we'll say self.tfuncs equals lfuncs. Now notice that the layer count is already decremented to remove the input layer, so this is of the correct size. And then we just need to handle the case where something is passed in. And in that case, let's do a little bit of validation first. So first of all, if they're not the same length, so if layer size, if the length of the tuple layer size is not the same as the length of the list layer functions, then this is a problem. So let's raise a value error and just say incompatible list of transfer functions. Elif. Okay, so they have to pass in a list of the same length, which means that the first one is for the input layer and therefore can't be anything. So let's enforce that layer functions 0th element is none. So if it's not none, then let's raise another error that says input layer cannot have a transfer function. Else, assume they did it right, and we'll say lfuncs equals tfuncs from element 1 to the end. Okay? So that will just strip out the none, and then it will just be a list of the appropriate size, and we'll be good to go. So self.tfuncs is a list of functions that we want to call instead of the sigmoid. So let's go down to the places where it's used. So instead of sigmoid, we'll say self.tfuncs of index, just like that. So this will be the function that we call, and it's called on layer input. Similarly, sigmoid is used here, so we paste that, and I think that's all of them. So let me run this. Oh, invalid syntax. If I equal 1. There you go, did its thing. All right. Let me go back and change this, because now this should be linear, and I should be able to get exactly 0. And by exactly, I mean really close. And 1. Just like that. Okay. So that appears to work. Now let's also try passing in parameters. So let's make a list called lfuncs, and it will just be a list that starts with none, sigmoid, and linear, like that. And then let me grab the definition of the network here and give it the tuple for the size and the list of transfer functions, and this should behave exactly the same. Tfuncs is not defined. Oh, oops, sorry. Layer functions, need to use the parameter. My fault. And there we go, okay, that fixed it. So let's try the other transfer functions out. Let's say Gaussian should converge quickly. There you go. Something very small, basically 1. And then let's try Tanch. Converges pretty quick too, so that appears to work. Let's check our validation. Let's make that 4. Input layer cannot have a transfer function. Fix my capitalization. And then let's try something that's not of the correct length. Incompatible list. Excellent. Okay, so I should be able to also do more layers, make this 2, 2, 2, 1, or something like that. And there you go, works out. And we can mix and match, and it works. So there you go. So there's all your transfer functions. You can add in whatever you want. Maybe I'll try adding in a step function, truncated linear. What else could you use? You could have that rational sigmoid one that we did in the C# version of this tutorial. You could put in whatever you want. So anyway, hopefully that's useful and you got it all lined up. And now, let me just double check that this works. Now you should be good to go. Of course, this is one of the ones that's going to take forever. There you go. Okay, cool. So I will see you guys for the next video, I guess. Later.